Alrighty, let's we just reviewed on radicals. You guys, if you're podcasting, just review pages 12, 13, 14, 15, and then we're up to number 15, and we're going to correct FGH because that's where I left on Friday, which of course I knew, and no one helped me remind me to where we left off because that's exactly what I said. They were trying to trick me and go back 3 pages, but I'm too smart for that. And now Lucas is rolling his eyes at my dumb jokes. Good to be back. Good to be back. Okay, so this one, let's do this one. If you have a number out in front, leave it out in front. 45 is not 15 times 3. You need a number on this list times another number that equals 45. And so, of course, that's 9 times 5. Square root of 9. Keep bringing the first number down. Square root of 9 is 3. So that turns into 3. And now you can go number times number equals a number. That's not what it is. There it is. Hut, hut, hut. Okay, giraffe. We did this 10 days ago. Who can break up giraffe for me? Who's got the breakup for 54? Thank you. No, oh, there we go. Couple people. Thank you. Kendra? Perfect. What's square root of 9?
3.
And what's 2? And what's 2 times 3?
6.
Isn't that a fun answer? 6 radical 6? That's just fun. Doesn't that get the dimples going? Super duper. And 48 is a big one, hard one, and a common one. 48 and 32, use the biggest one. Who's got the biggest one? 48. Thank you. Good. 16 times 3. What's the square root of 16? 4. And what's negative 4 times 4? Negative 16. All right. If this was positive 16, would you square root the 16? No. You only square root the 16 if it's a square root of 16. Just because it says 16 doesn't mean you square root it. It has to be square root. As discussed, 16 does not equal 4. Okay, do the rest of the homework. Give you up to bottom page 17. And as promised, tomorrow we'll correct the homework. Actually, that's talk about this guy. Everyone go to D. And let's talk about the hint. So no one, 32 times 10 for 320, but that doesn't help us on the list at all. It has to be one of these numbers, so divide by 2 or 3. Start punching, come on, Xbox. Divide by 2, divide by 3. Figure out what you divide by to get a perfect square for that one. Don't say anything, please. Let everyone figure it out. I'll give you another little bit. Leave this on next class. Of course, I just erased the numbers. Okay, number 1. Okay, so divide by 2 or 3, it didn't work, did it? So what do you have to divide this one by, everyone? Brittany? 5, and what times 5 equals 320? Good, okay, so if you can't divide by 2 and 3, if it doesn't work, 160 isn't good enough, 3 doesn't divide by 3, but 64 times 5 does work. What's with the eyes? You think you got another one?
320 divided by 2 is 160.
Yeah, and that's not quite on the list. 144, 169 would be the next one. So close. Remember, it's multiply, not add. Square root of 64 is 8, and then you have to know what 8 1/8 times 8 is? And if you have 1/2 of $20, how much money do you have? What's 1/2 of $20? 10. So divide by 2. Multiplying by 1/2 is like dividing by 2. If you have 1/3 of $30, how much do you have? Multiplying by 1/3 is the same thing as dividing by 3. So here, you can know that multiplying by 1/8 is dividing by 8, which just means 1 radical 5, or you can go top times top, bottom times bottom, or myself, I would reduce first and get 1 that way. You don't need to write down the 1, but the answer is radical 5. So if your hockey number is radical 5, you could put 1/8 radical 320 on the back of your jersey. Oh, look at these girls, they're so sad because hockey's over. Cheer up. It's not. Yay. That's even better. Plus the Flames are doing good. They're almost in 7th place. Oh, Flames. Okay. So that rest is homework. And then we got the quiz coming up real quick. After that, it's not a great time, but that's the only time we got. So, quiz is probably Wednesday. So you're going to be studying tonight. Again, we didn't have anything over the break, so we're happy. So now it's go time, crunch time, and learn radical time. But first is a quiz. We got to make sure you're perfect on the quiz. So the quiz will say it's Wednesday. It's a possibility of Thursday. But we're going to move on. So the stuff we're going to do now is not going to be on the quiz. It's just going to be on. Don't forget what we did 18 years ago. We estimated square roots. We did, well, remember those wave equal signs back in 1972? Yeah, we did those. And so you got to go back to page 1 of this handout and go all the way to page 16, 17, and that's on your quest. In fact, you can write that down on the bottom of page 17. Go to bottom of page 17. Write down the quest. So everything up to page 17, so we're not quite there yet. We still got perfect cubes to deal with and honor. So we are done page 15, so let's go to page 16. That's just one more. You go over here. Well, hello again, podcast people. Then one more. Okay, so we're going to perfect cubes, which is going to be the same thing. I'm not going to ask you as many times, but we're going to do the perfect cube list. This is the perfect square list. Now we need to know these numbers. We need to know what number is 2 times 2 times 2, and 3 times 3 times 3, and 4 times 4 times 4, and 5 times 5 times 5. I'm not going to worry too much about these, but I certainly am going. Everyone should know what 10 times 10 times 10 is, because that's the fun one. Okay, so we'll go ahead and write down multiples of 8 are 16, 24, 32. So if you see any of these numbers, you're going to use 8, probably, unless you use 64. But these are cubic roots now. That's a 3 somehow. And then 2,000, 3,000. Anytime you see this, you think right away, I'm going to use the cubic root of 1,000. You're going to break them up the exact same way. You're going to use a number on this list. So 8, 27, 64, 125, and probably 1,000. Times another number that equals 6,000. That equals 320. In fact, that's a 5th root, unfortunately. And so forth. Yes, sir.
64, is that?
128.
Oh, 128.
Yeah. 64 plus 64, or 64 times 2. The exact same steps. You can underline that. It's exactly the same thing we're doing, except we're not using the perfect square chart. We're using the perfect cube chart. Now, what I should do as well is on the other side, instead of putting 8, you should also put -8. Instead of putting 27, you should also put -27. Because you can use the negatives as well, because it's a cubic root. So cubic roots can be negative. Square roots can't. That's impossible. That's an imaginary number. No square roots can be negative. But if you have a cubic root, if you have a cubic root of a negative number, it's a negative answer. Cubic root of -8 equals -2. -2 times -2 times -2 equals -8. All right, thanks for working so hard and write down what I did. Let's move uppy, extend, and do this question. So, when we see 6,000, 2,000, 3,000, we're happy. But we have to realize that this is a cubic root, okay, because this is different. Square root of 64 is a different answer than a cubic root of 64. Okay, we're now on to the cubic roots, which means what number times itself 3 times equals 64. Okay, so this one, I just erased the list, but we're going to use 1,000, cubic root of 1,000 times the cubic root of 6. Now don't lose this cubic root sign just because you're used to square roots. Most of the time it's square roots, but if it's cubic roots, you got to keep the cubic root. Now, that's the perfect cube. What number times itself 3 times equals 1,000? Show me with your fingers. High five. Good. So you turn that into 10, and you got the silliest looking answer you've had in your entire life. 10 cubic root of 6 is the answer. Full marks. Don't do anything else with it. Your goal. This could be a numeric response question. So tell me what A plus B plus C equals. Write it down, please. Thank you. Great money. Okay, so this would just be 10 plus 3 plus 6, if that was a question, numerical response. Okay, fifth root is, I have no idea what a fifth root is, but we know that a fifth root is a fifth root times a fifth root. So 1 times 1 times 1, 5 yourself 1. 1 is useless because it's always 1. Now what's 2 times 2 times 2 times 2 times 2? Somebody? 32. Good job. Said the kid. And 32 works. 32 times 10. I'm not going to try to get you to spend 20 minutes on a fifth root question, okay? So let's go 32. That's the easiest one. Who knows that? Well, hopefully you know it now, but if you don't, just do 2 times 2 times 2 times 2 times 2 on your calculator or your fingers and toes. And what's the fifth root of 32? What number times itself 5 times equals 32? 2. So this is something we're not going to see very often, but if you do see it, again, you have to know how to do it. These, again, are like estimating questions. We're not doing a lot of cubic roots, but you'll see a splash of cubic roots on your quiz and your test. So you have to know how to do them. You cannot afford to get 0 on these. These are less familiar, but the first thing you should do, again, is write down the cubic root chart. 8, 3 times 3 times 3, 27, 4 times 4 times 4, 64, and then use it. What am I looking for? Red. I like this one. Again, cubic roots can be negative, so instead of using 8, you're going to use cubic root of -8. Okay, so cubic root of -8 times the cubic root of deuce. And this is the perfect cube. What number times itself 3 times equals -8?
2.
Close. 2 times 2 times 2 is positive 8. -2 times -2 times -2. Okay? So that turns into -2, cubic root of 2, and there's nothing else you can do with that. Leave that if you start making up stuff, you're gonna lose a half mark. That's the perfect answer, leave it like that. All right. I'm gonna give you just a couple minutes to work on a couple questions, because that's such a small section. I think we need a couple more examples. So if you go to the next page, go ahead and maybe just do these two. While I take attendance. Sydney, we're not going to mark a late first day back, but tomorrow we'll be late. Okay, perfect. Let's go. Do I have internet now? Yes, I do. Power teacher. Huh, maybe I don't. That's one, George, you can have. All right, no Ruby. Kale. All right, you're probably done one, so let's correct the Mundo and then go back to entire radicals. Oh, okay. It didn't work. It was working. Okay. Enough of that. Let's go on. Now the problem with these is, again, we're not going to do a lot of them. So it's like estimating roots. It's a little better than estimating roots because we just started this after the break. However, we're not going to do a lot of these. So you only want to study star these just to make sure you understand what to do. Because if it's a square root, we do 16 times 3. It's not a square root, so we don't do 16 times 3. We do what, everyone? Pardon? 8 times 6. Good. Cubic root of 8 is 2. Because 2 times 2 times 2 equals 8. So that's what cubic root means. What number times itself 3 times equals 8. So 2 cubic root of 6. Sorry, that's cubic root. Hard to write in smart wordy terms. In square root, this would be 64 times 2. It's not a square root, it's a cubic root. So if you put 64 times 2, you get, never mind, it is 64 times 2. Because it's cubic root of 64. That was funny. However, it's a little different. Now it's the cubic root of 64, not the square root of 64. So it's not 8, it equals, what, somebody? 4. Good. And just to make a point, let's go ahead and put this question E here. If I was to give you the cubic root of 128, or sorry, negative 128, you do the exact same thing, except for the cubic root would be negative. So write that down, please. If the cubic root is negative, you use a negative. If the cubic root is positive, you use a positive. Okay, so if it's positive, the answer is positive. If it's negative, the answer is negative. Hi.
So if you had a number in front of the radical, would you take the negative one and multiply it by it?
You sure would, yep. So you'll have it right here. Question, your chocolate bar ready? Maria won free chocolate bar. Maybe I should write you like inside. Exactly, inside. Okay. That's not very big compliment. I mean, at least as you eat. And keep you human. Superstar. Okay, so rest is homework. Yeah, Natalie asked a great question on D. If there's a number out in front, you just leave it out in front and multiply it at the end, just like we did with square roots. Now, your quiz is on that stuff. And on your quiz tomorrow, there's no cubic roots. Okay, so write yourself, this is not on quiz tomorrow. It'll be on the rest of the evaluations. Tomorrow's quiz is on mainly square roots, mixed radical square roots, and a splash of this question, which I don't have on the board, but I reminded you before the break we did this. The podcast people, write this down. 3 square root of 25. And square root of 25 is 5. So don't put 5 radical 5. Don't try to break it down, and I don't know what you break that down anyway. But there is no radical part in this answer. Okay, so you don't always have a radical part in your answer. This is on the list already. So square root of 25, you just turn into the number 5. Remember, the question is what number times itself equals 25. So you just turn it into 5. Okay, got it good? All right. So that's the type of questions that are going to be on the quiz. Tomorrow, no cubic roots, okay? And that's what we'll probably start with, unless you have any questions on the homework. I had another thought. What was the other thought? Oh yeah. So what we're doing next, entire radicals, is not on the quiz. You usually don't do it. It's a rare question. In fact, I think we already did it. But let me remind you how to do it. Page 14. Look at page 14. I just don't want to do this and then get you confused and have anybody do it. Because if you do this more than once or twice on a test, you're going to get them all wrong. Okay, so entire radicals. Look at page 14 on how we did entire radicals. I kind of remember doing this with you 18 years ago. When I ask you for an entire radical, it means you have to put everything entirely under the radical sign. So you have to do the opposite of what we usually do. So now we're going to do the entire radicals on cubic roots. So now you look at that. Go to the top of page 17. And there's 2 silly questions here on the top of this page. So first thing you have to know is you have to understand if this is a rare question, and you have to have everything under the radical sign. So if there's something not under the radical sign, you have to turn that into a radical. Okay, so I'm going to do the hard one for you. You can do a similar one in B. For A, we have the 4th root of 3. So we have to turn the 2 into a 4th root. Because you can only multiply 4th roots with 4th roots, cubic roots with cubic roots, and square roots with square roots. We were used to doing square roots, like we just looked back on the previous pages. And to get a fourth root, you just multiply 2 times itself 4 times. Okay, so write down 2 times 2 times 2 times 2, or if you want to, write down 2 to the 4th. What's 2 to the 4th? What's 2 times itself 4 times, somebody? Sweet 16. So you put 16 there. How did you get 16? You multiply 2 by itself 4 times. And now you just simply multiply 16 times the 3, and the 4th root times the 4th root is a 4th root. Now it's a little harder when you're talking about cubic roots and 4th roots to do this. I'm not going to give you 5 questions. I might give you 1 of these. I might give you 1 or 2 of the square roots. That's it. But what have we learned? We don't want to get a 0 on a question, because that's like, I don't know, 4% of our final mark. We don't want to look at this and say, I don't know, move on. I can't do that. You can do that. Everyone do that. You break up and into a cubic root times a cubic root, and your final answer is a cubic root. Okay, so go ahead and try B, your own. I sit on my rear. Well, just imagining all of your Easter Sundays right now, what you guys did, what you ate. Did anyone have an Easter egg hunt? Like, you know, nice. You know, cool. We had like 5 Easter egg hunts. We're gonna have one other one tonight. Probably the last one. So much fun. Usually I hide them. I drive to Nanton and hide them, so I don't see my kids for days. It's awesome. That would be awesome. There you go. Anybody go to the Nanton candy store? Anybody? Hey, you go. You did. I told my kids they have 75 cents to spend. Go to it. You're welcome. Between the 3 of them, so 25 cents each. I think I'm spoiling them. No, I don't think we spent 20 bucks on gas. How do you get what goes in here? You do -4 times -4 times -4, which is what? -64, which, and -64 times 7 is -420 plus 28. Is that right? Okay, so very minor concept. I'm not going to ask you that once, but I'm going to ask you once or twice. And probably 1 square root, 1 cubic root. That would be that. You have to know how to do it. You can't just leave it blank. Please don't just leave it blank. Okay. Here comes some challenging ones with letters and variables. What's the perfect square chart for x? What's x times itself? Everyone? X squared. What's x squared times itself? X to the 4th. What's x cubed times itself? Add exponents. What's x cubed times x cubed? X to the 6th. Those are all perfect squares. X squared, x to the 4th, x to the 6th. What do you think's next? X to the 8th, x to the 10th. All the even exponents are perfect squares. And that's what we're going to do. We're going to break these up. And it's going to be different. Okay, different is good, especially for your brain. So you could put a squared times a to the 5th, but that's not the biggest one. What's the biggest square we can use without going over to 7. We can use a to the 6th. Why is a to the 6th the perfect cube? Because a cubed times a cubed, 5 times itself, equals a to the 6th. Right? I guess it's a little easier to visualize with it right now. You guys agree with that? That's the exponent laws. You add exponents. Okay, so the square root of a to the 6th is a cubed. Because a cubed times itself equals a to the 6th. So we can break this up just like we have the square root of 64 equals 8. The square root of a to the 6th is equal to a number, a cubed. So there's your perfect square, and there's your leftover radical. So basically, you're taking the highest even number that you can, and then leftover part is going to be radical t. Okay, unless it's even. If it was an even one, if it was a square root of t to the 6th, that it would just be t cubed right off the bat, because that's a perfect cube. So try B. Try your best. It's going to be hard to do it with only one example, but again, this isn't a major concept. This is just a quick see it, look at it, maybe one questioner. But break up the t to the 9th to something times something, and you're going to have the biggest even exponent that's before 9. What's the biggest even exponent before 9? And what's the biggest even exponent before 9, everyone? 8. Yeah, just... And now you ask yourself, so this is like square root of 25, where you turn it to 5. The square root of t to the 8th is an answer. What number, t to the what, times itself equals t to the 8th? Everyone? T to the 4th. What? I thought you had a weird answer before. This is ridiculous. T to the 4th, radical t? Let's protest. Let's get out of here. I don't want to do this. I love this stuff so much. Ah.
So you would so if you were to multiply t times 4, then it would be because you add.
Yep, exponent rules. T to the 4th times t to the 4th. In grade 7, I think, we learned equals t to the 8th. Then we'll also be doing it again in about a day. We'll review the exponent laws. Okay, cubic root, similar, except for the cubic roots are now x times itself 3 times is x cubed. X squared times itself is x squared times x squared times x squared. When you add those up, what's the exponent you get? X to the 6. What about x cubed times x cubed times x cubed? What is that? X to the ninth. So now we're looking at whatever exponent is closest to 369, multiples of 3, times another number equals x to the 5th. So this is a cubic root times a cubic root. I can't go to x to the 6th because I only have 5 x's. So I'm going to go with x cubed, because it's a perfect square, perfect cube, pardon me, times x squared. And what's the cubic root of x cubed? One number times itself equals x cubed. X times itself 3 times equals x cubed. So x cubic root of x squared. Don't worry about this too much. Look at it before you have a test. and you'll be doing a lot more of this next year. It's basically just, this is what's coming up in grade 11. And D, let's do it together, help each other out. What number is 7 closest to without going over 3, 6, or 9? So x to the 6th, hopefully you guys can see this on the podcast, times what equals x to the 7th, 1, and now you turn this into, that's a perfect cube. What number times itself 3 times equals x to the 6th? X squared times x squared times x squared equals x to the 6th. And then you just leave this cubic root of x like that. Any weird looking answer? It's a multiple choice. Hopefully that will match your answer. Let's do one more. Any questions? B, just take a look at it. And again, you're not going to have a lot of these with no letters in the variable, hardly any at all. But know how to deal with them if you do, or when you do have a very little splash of them. So take a peek at example 4B, and how do you think you tackle this? Have you done this before? Radical 18? Okay. Have you done this before? Well, we barely just did it. So you're going to treat them kind of as separate. You're going to deal with the number part separately than the x part, if that helps you, or you can deal with them at the same time. I'll show you 2 ways to do this. Do whichever way you like. There you go. Okay, so one way to do this, radical 18 x cubed, is to break down the radical part first, so ignore the x part, into radical 9 times radical 2. And then break up the x part. Who remembers how to do that? And that was a big smile. Was that math? Yeah. Okay. What would perfect square be for x cubed?
Perfect square for x cubed would be, if I did x squared.
Perfect, yep. Okay. Good job. Man, I'm writing neat today on that question. Good. Now, let's do the perfect squares. What's the square root of 9? 3. What's the square root of x squared, everyone? What number times itself equals x squared? X. And leave the radicals. And now, put the numbers together and the radicals together. So, grand finale for this one, would you put the 3 and the x together, and the radical 2 and the radical x would all go under one radical sign. Okay, you would separate it like that. I wouldn't do it like that, but I think it's probably easier if you do it like that. The other way you can do it is take the perfect squares in front, and then the leftovers on the other one. So 18 is 9 times 2, and x cubed is x squared times x. And then you square root this into 3x, and write down the radical part in the second part. So write them both, and your brain can choose whichever way you like the best. You break down the numbers separately and the letters separately, and then combine them at the end, or just put all the perfect squares first, all the non-perfect squares second, and you can always square root perfect squares. Okay, so I already talked to you about homework is on page 17. You know what, why don't we do another one of these? Go ahead and do C and D. We'll do the two hardest homework questions. Actually, those aren't homework questions. Okay, we'll get these two hardest ones done to get to homework. Okay, so do C and D now. Podcast people, my attire is I'm wearing a black Under Armour fish shirt with charcoal Under Armour golf pants and black Salomon shoes. Basically the same outfit you've seen 72 times this year. But it's so comfortable. And a black mask. All right, podcast people, pause. Try to do C and D. Just do your best. Look at the questions we have. It's not a big deal if you don't get this because we haven't done many of them. But try them before we correct them. So unpause when you're ready. All right, let's do the first one. I'll do them both ways. I'll do the first one the first way, the second one the second way. I think I gave you enough time to do C, so let's see how you did. So we got 32 is 16 times 2. Y to the 7th is y to the 6th times y. And the hard one is z to the 8th is actually a perfect cube. What times itself equals z to the 8th, everyone? Z to the 4th. So there is no radical z. There doesn't have to be a radical z. There doesn't have to be a radical anything. That's a perfect square. So now these are perfect squares for what times itself equals y to the 6th, y cubed. And the z is just z to the 4th times z to the 4th equals z to the 8th. And now you put all of the numbers together. When I say numbers, I mean everything is not a radical is a number. And all the radicals together. So if you put all the numbers in front of the radicals together, you get this. And then everything under the radical sign is 2y. If I get that, if you got that, just pat yourself on the back 25 times. That is awesome. Did I record? Yeah, I recorded. Z to the 4th moves up here because it's a number. It's not under the radical sign. Okay, do I care if you got that? I don't care if you got it. Hopefully you got part of it. Hopefully you got, and you should definitely get the 32 part because we've done that, well, besides the big long break we had. But you're not in kindergarten. You can forget everything. It's in your brain. Your big fat brain has got this all. Okay, try to do D. D is cubic roots. So the perfect squares, or perfect cubes for cubic roots are x cubed, x to the 6th, x to the 9th. Those are the numbers that are the perfect cubes. And then the 40, remember you're doing 8, 27, 64 for the number part. Okay, try D. Write down C. I'll give you another couple minutes. Forgot to say pause, 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 pause. Okay, L cubic root. I'm going to do this where I put all the perfect cubes first and all the leftovers over here. Okay, anybody break up 40? Yep. Good. So cubic root of 8 is the perfect cube. 5 is the other part. Okay, how about x to the 4th? What? Pardon? Not quite. It would stay if it was square root. But the perfect cubes for x are these ones. So what's the biggest one without going over? Pardon? Yep. X cubed times x is x to the 4th. And we can cubic root x cubed. And then y to the 9th. Oh, that's what you meant. You meant y to the 9th stays. So y to the 9th is a perfect cube with no leftover parts for the y. Because y cubed times y cubed times y cubed equals y to the 9th. That's why this breaks down into y cubed. What's the cubic root of 8? 2. There he is. That's a little sneaker. And what's the cubic root of x cubed? X times itself equals x cubed. 3 times, right? X times itself 3 times equals x cubed. So that's the perfect cube part, and then you just write down the leftover part there. I don't care if you want to do it, break up the radical part first, then break up the x part first, then break up the y part first, or if you want to do it this way and do the perfect square first. This might be easier for you, I don't know. It's certainly a little easier to look at when you have perfect squares times non-perfect squares. But it doesn't matter. The same thing, you'll get the exact same answer. So we saw you outside, buddy.
Yeah?
Yeah.
Okay, I have a fast car.
You're pretty fast. You should join track.
Yeah?
For sure. Who's joining track? Hopefully there's track. Yes. Get it. Get your hands up. Run, run, run. Jump, jump, jump. Throw, throw, throw. Even if you haven't tried it, do it anyway. You might be the world record holder of javelin, even though you haven't even touched a javelin yet. Never know. I was terrible at throwing events. Whenever we did grade 6, 7, 8 track meets, I think we threw a softball. I could not throw a softball at all. I got a lot of purple ribbons. That means the best. Purple and orange. It's like the best. Okay, we're gonna do homework. Go ahead and finish off these guys. And do your best with number 9 and number 10. Again, not big giant concepts, but you should be getting better. And tomorrow we have a quiz on perfect squares, mainly on the stuff right here that we did. Okay, breaking down radicals. That's going to be your quiz. This is not on your quiz at all, but this will be on your quiz, which is coming up right after. So quiz tomorrow on Tuesday. Study, I should just tell you what pages to study. So pages 12, 13, 14 to the middle of 14. Page 12 to the middle of so no entire radicals, is your quiz, mainly on that part, plus perfect squares, the one we did there on Z. And podcast people, I'm pointing at this one that we did. Okay, so that's tomorrow. Quiz, big quizzy. You have to break down radicals, and then if there's a number out in front, you got to leave them out in front and multiply them at the end. Okay, that's our big giant quiz, and then quiz is going to be either Wednesday or Thursday. They haven't decided yet. I guess you can clean your desk now. Oh God, that's an awesome day! Ha ha ha. Steve.